In today's podcast, we will be looking at axonometric projection. We'll be doing a step-by-step breakdown of an example of a question. As we discussed earlier in the class, there are three different types of axonometric projection. We have trimetric, dimetric, and isometric. And here we can see a 3D model of each. In today's class, we will be doing an example of an isometric projection question. Here is today's question with the given dimensions, and on the right, we have a 3D model that I've made up before the class on SolidWorks. This is very helpful for both students and teachers, as it will help the students to visualize the object that they will be drawing. So the first step of drawing any axonometric projection question is the construction of the crow's foot. As we discussed earlier in the class, the crow's foot is constructed differently for trimetric, dimetric, and isometric. Here is an example of an isometric crow's foot. As we can see here, the angles are all equal at 120 degrees. As we can see here, the crow's foot represents the x, the y, and the z axis. So the x is going off to the right, the z to the left, and the y is progressing straight up. Once we have determined the crow's foot, we then begin to construct the positioning for the plan and the elevation. These are some of the key points that we need to consider when positioning the plan and the elevation. The projection lines must be kept perpendicular to this side of the crow's foot, and then once we get them, we can progress to doing exactly the same thing down here, so we just repeat the process down for the plan. So I will now go through a step-by-step how to get the students up to this point. So our first step is going to be projecting the lines into elevation. So again, as I mentioned earlier, these lines must be kept perpendicular to this side of the crow's foot. We will then draw a line perpendicular to these red lines, and the distance away will be h. On an A3 sheet, this distance from here to here is usually between 50 and 100 millimeters, but this is at the student's discretion. The center point, so the next thing we'll do is just draw an arc, and the center point of the arc is here, as you can see. It's located between the two extreme points. So the next step is where the arc intersects the middle line here, we're just going to draw a point, and you can see here, you're going to project your lines as shown. So to do the plan, we're just going to do the exact same steps again. It's going to go perpendicular across, this time, the bottom of your crow's foot. Again, the semicircle is constructed with the center point being here. And again, you just project these lines as shown. So here is going to be the starting point for your elevation, and down here is going to be the starting point for your plan. And in the middle, we will get the starting point for our isometric drawing. Again, this is very important for the teacher to remember to tell the students that the distance from h from here to the elevation will have to be the same as the distance from the bottom of the crow's foot to the plan. So now that we've established the positioning of the elevation, students will use the dimensions to draw the elevation in this position. So up here. And the students will repeat this in the plan down here. And a prompt just for teachers is they will probably have to stop the class to explain to the students why the plan is at this orientation here. This is very important, as we can see that this point will be the same as this point here, because it is very easy for students to draw their plan at the wrong orientation, which would result in the question not working, and it will be very skewed. So students can get their heights and their widths from the question, and this should be nothing new to students, as they will have all done orthographic projection before this. Now that we've drawn the elevation and the plan, we can begin to construct the isometric view. So just another prompt for teachers is we're going to have to tell the students to label all the points, because there will be an awful lot of lines in this question, as I will show you in the end. So we can see here, we began by bringing this point up, and we got the same point in the elevation and brought it down. So this is the point we're given. This is point 1 in our axonometric drawing. So this is just another key point. You can use the SolidWorks layered solution to show the students how you bring the points down. The layered SolidWorks solution will be also in the OneDrive. So just for a bit of clarity here, we started off by doing the whole base together. And again, we brought up the base points in our plan. So label the points in the plan and the elevation to make it easier to follow. And just here we can say to the students, maybe start A, B, C, D, etc. And up here we can tell the students A, B, C, D again. This is just for clarity, and you can tell the students maybe if they have fine liners or different color pins, it will make it easier again for them to distinguish between the different lines. So in this example here, we are doing the head of the clock. So again, the students can change color and they can bring their lines straight up and they can bring their lines down from the elevation. So all of these lines will be parallel. That is very important. So the students will have to use sliding set squares, etc. So accuracy is key. And again, the teacher should be telling the students that labeling is vital. So to split up the curve, we will split up the curve in an isometric view. We must break down the curve into 12 points. Most students will have done this before with 60-30 method and will also be familiar with this method, as we can see here. We'll use this method today for this question. To make it easier for students to follow, we have put this question in this orientation here. So students will be used to seeing this in their orthographic again. So now we will project the lines straight down onto the plan, and this will make it easier for students just to visualize what they're going to be doing in the next part of the question. So step 8, in this slide we are showing how points of the curve are brought up from the plan and down from the elevation. So we bring curve points vertically up from the plan, so straight up, just as we showed in the previous slide. And we're bringing the curve points parallel from the projection lines in elevation. So it's going to be similar to every single point. We're just going to be bringing them parallel down to our axonometric view in the middle. So here we can see, we can just match up the points here again. Again, I must stress, we'd have to tell the students to be labeling, and we'll start to see a curve being formed. So, as I've been saying throughout the question, this will show us how important that labeling is, because if students aren't labeling and their line weights aren't correctly, we're going to get a very messy finish. Here we can see it without the construction lines, and it looks quite well. So that is all.